Hello team, today's challenge is periodic spelling, where we're given a word like neon and we need to try and spell that with the atomic elements. So in this case, I'm pretty sure Ne is neon. And then we have oxygen and nitrogen, right? So those three elements, if we were to join them and lowercase them all, they would be equal to neon. And we have to do that with words like rationale and yarn and carbon and noisy and bicycles. And if we get a value like value, that can't, there's just no way that we can get these atomic elements to fit into this string, then we just return an empty array, which is excellent, okay? With this, we're going to use a little bit of recursion and a little bit of backtracking. And in fact, we've seen backtracking a few times. The most recent that I found was the longest domino chain, right? Where we needed to get the best string from the system. Now here we had some very complicated code, right? It goes quite a bit, and that's because we had to be able to flip the domino end for end. So if it was like a 4-5 domino, right? 4 on one side, 5 on the other, then we could do either 4 and 5 or 5 and 4 on that chain, and we had to be able to try both. And then some other logic in here, pretty good stuff. It is not going to be this complicated today, thankfully, but that one's out there too, right? And it also uses something called backtracking, which is a way of checking each individual path as we go through, right? So we're going to check the paths. If the path fails, we back it out and try a different path. And that's the whole goal. So with that, we're going to grab our elements. We're going to copy this into our code and get started. Right here, if I could jump to the top, we're going to go const elements, okay? That is going to be all of these. Now today, we only have 1 and 2 character elements. There are some 3 character elements. They're usually placeholders, is my understanding, for until the international standards body that decides on these names picks a better name, right? But if your array had those 3 character elements, then you might have to do something a little bit different, just a little bit. I'll show you exactly where that is. But just calling that out, that today we only have 1 and 2 character elements, but there are some 3 character elements. So fun times. We also need these in a lowercase format. So let's do that right away by going down here, and we're going to set that to element map. Okay, so predictably this is going to be a map, and inside of here we are going to go elements dot lowercase map. So uppercase map, lowercase map, doing 2 different things. We have that element, and we are going to return an array, right? The first one is going to be the key. The key is going to be that element dot to lowercase, just like this. Excellent. Okay. So our key is going to be the lowercase version, and our value is going to be whatever that current element is. Okay. Hopefully that's making sense, because that way we can search on the lowercase and access the lowercase. And then when we need to, we call lowercase and we get the uppercase version, which is good. Okay. Inside of here, this is really simple. This is going to be, what are we calling it here? Get elements from string, like this, and we're going to send in word. Excellent. Okay, this is going to be our recursive function, the function that does it. And the reason that we're putting it as its own thing is because one of our controls is going to be null. Null is going to be how we know if we found 0 results, right? That's how we back it out if we need to, or if we didn't find anything, then we just return null to say there's nothing here. So there is a chance that this could return null, which means that we need to use the nullish coalescing right here to always return an empty array. Okay. With that, all of our work happens up in here. So we create this function, send it through as word. We can still do that. And notice that we don't need any extra arguments here, right? We're just going to work on word. And as we go through, we are going to reduce word down. That's going to be our main argument that we pass in. And we're only ever accessing the first letters of word. either the first letter or the first two letters. Okay, so that's good. The first is once we're in this function, the first step is how do we exit, right? How do we exit if everything goes proper, right? Well, we do that by checking if word actually has weight, if it has characters, right? So if word equals an empty string, then return that empty string. Okay. If we go through all the steps, and you'll notice that I added some returns in here, we're going to come back to that. If we go through all the steps and we didn't find anything, then we return null. And that's that control, right? That's how this might end up being null, which is why we need the nullish coalescing, okay? To return something that we actually do want. Inside of here, we have our for loop. And the question becomes, what are we iterating on? When I did this, I really wanted to iterate on the word itself. But I quickly learned after a little bit of research that what I should be iterating on is the character count. The element count. One character or two characters. Okay. So in this case, the super secret answer is one or two, right? That's the whole thing. So let I of one or two, just like this. That's where we live. Okay. Inside of here, we are going to check on one. If everything goes to plan, we're going to return that. That's going to end this recursive function, kicking us back to the main function and ending the cycle. If one doesn't find anything, then we jump to two. And if two finds it, then great, we return that. Not a problem. Everything goes according to plan. If we don't find two, well, then we skip out to null, at which point we return our empty array. So everything is kind of working in here. And if we added those 3 character ones, well, we can just go and add an extra thing. Okay. In fact, we could leave this in here right now. It's not gonna do anything other than extending our loop by one iteration. Okay. But we don't have those, so let's keep it simple for now and move on. Okay. So this element is going to be word.slice. We are slicing from the beginning to whatever I is. Okay. We're peeling off those front letters and trying to do something. What are we doing? Well, we're checking if element map dot has L, right? And it's going to, we've created a key here. In fact, one thing that we probably should do is lowercase this to lowercase, just to be sure that we always do that, right? All of our words today are lowercase. So if you miss that, just like I might have, it'll probably still work. But we should lowercase that, which brings us back to here. If this is here, then we want to do something. What do we want to do? Well, we want to get the result. Okay, we want to go further, right? So it has that element. Now we're going to get elements from string. And what are we sending in? Well, it's going to be word.slice I. Okay, so right here we got the first 1 or 2 letters. Now we're getting everything else. Okay, and we're going down and we're trying the next step to see if that works. If we got a result, so if result does not equal null, right? Because remember, we return null if we didn't find anything. So if result does not equal null, then we can return, right? And that's the magic of this, is like here we go. So we go element map, dot get, whatever that element is, and then whatever the result is. And we spread it out so that it all is on the same level, the same depth, okay? So element map.get, that element, the result, we should be able to test this. It absolutely works, okay? One little thing that I like to do, okay, and this is me, I am a big fan of returning early. So if there's an opportunity to say, hey, we don't need to do all these lines of code, we can just return, then I do it. And that allows my conditionals to all be in line. You'll notice that we have one conditional nested in the other conditional. Well, if we flip this really fast, we bring this down, indent it out, and then we bring this back, and whoop, it's jumping around. We bring this back and we reverse it. Okay. So now we're saying if element map doesn't have that element, then continue. Okay. And what continue will do is it will either go to the next one or it'll go to the end of the loop, whichever position I'm in. And this still works, but I feel like it's just a little bit cleaner, right? My conditionals are lined up a little bit better, and it's a little bit more explicit, I find, right? Which is pretty handy. So again, here's where we end today, okay? We started off by bringing in our data and then creating the data that we actually use to get this done, okay? We figured out that we need a lowercase key, and that lowercase key is going to allow us to access that uppercase variant, okay? From there, we can we set up our recursion. If our recursive function returns null, we return our default. And then inside of our recursive function, some very simple logic to do some backtracking, right? So using the loop. This 1 and 2, I feel like it could have been an if statement, but it doesn't work. The reason that it doesn't work is because the conditional would require some extra code, and it just gets a little bit messy. At least in my testing, it's still early here. I'm still waking up, so I might come back to it later on and go, oh, that was the solution, right? And that's okay too, being able to come back and do that. But for today, we loop through just 1 and 2, right? As an iterator. Could we have done this as a traditional loop? Absolutely. No harm, no foul, but this gets it done. We sliced it off. We checked if the element map even has that element. If it doesn't, we skip it. Otherwise, we try again, right? We try with the next section of the string, and the next section and the next section. And so long as we aren't getting null, we keep going until it's an empty string, at which point we get out of this loop, okay? Hopefully that's making sense, because my brain's a little bit foggy. It is very early this morning, and I might come back to this later and go, oh, there's a better way, right? Again, not every solution, just hopefully one good solution. If you liked it, if you hated it, if you found a different way, hit me up in those comments. Otherwise, today this has been Periodic Spelling, and I will see you in the next one.